Hello, I'm Dr. Tim Floyd, Associate Professor of Mathematics at Georgia Highlands College, and in this video we're going to talk about special factoring situations. In these next few moments together, we will talk about understanding how to factor some binomial and trinomial factoring patterns that have squared numbers involved, and thus make the factoring process just a little bit simpler. Now, what I have here are some tables I've found in a document that I have provided you, and if you'll notice, we have the numbers from 1 to 29, and the second column has the squared values of each of those numbers. Some of these should be familiar, like most of us know that 9 is 3 squared, but as you get to these larger numbers like 11, 12, and on up higher, there are problems that you'll encounter in this course that will use these higher leveled squared numbers. And if you know them, you'll recognize the pattern of factoring just a little bit easier. I would highly recommend that you make a set of flashcards with these numbers on one side and the squared value on the other, and have a partner maybe and work on memorizing these, and it will tremendously help you in your factoring. These are the patterns that are considered the special factoring patterns that traditionally we discuss at this point in this course, and certainly these are patterns that the quicker you can bring these to your memory, the easier many of your factoring problems will be. So in this case, if you notice, if you have a squared, and they're all signaled by squared numbers or squared variables or variables with even powers. So we have a squared minus b squared. If you take the square root of the a squared and the square root of the b squared and simply use those to fill in the pattern, then it can factor very quickly. Now in the second pattern, we have a squared plus 2ab plus b squared. So the middle term is formed by taking the square root of the first term, which again should have a perfect square number and a variable to a power of 2 or an even power. Same on the ending term, should be a number that you can take the square root of evenly and have an even power or the power of 2, so that when you take the square root of this and the square root of this and multiply it by 2, you should have the middle term. If that is the case, then this is the pattern of factoring, that the square root of the a squared term added to the square root of the b squared term, then that squared is how this will factor. The companion then is when you have a squared minus 2ab plus b squared. Same thing essentially as the second pattern, except your middle of your, when you factor this, the middle of your binomial will be negative instead of positive. And finally, this pattern, a squared, b squared, where you have perfect squares at the beginning and the end, but a plus sign, this will not factor. And we'll look at an example in a moment and hopefully demonstrate to you that this will not factor. In this first example, you will see that we have 4, which is 2 squared, and 25, which is 5 squared. We have x squared and y squared, so we can write this problem in this format. We have 2x, which is being squared, and then we have 5y, which is being squared. So now if we go back then to the pattern, that a squared minus b squared is a plus b and a minus b, then we simply complete the pattern by writing 2x plus 5y times 2x minus 5y. And if you want to check this, you can, but this is the pattern of how this will factor. Now I will say that it does not matter which of these is first, so you could have a minus b first and a plus b second, which then gives us another correct answer of 2x minus 5y times 2x plus 5y. So either one of these should be considered as correct answers if you are working with an instructor. So now if we look at this example, we see that 9 is 3 squared and we have x squared. We have 16, which is 4 squared, and then y squared. And it appears that this would fit the pattern of the a squared minus 2ab plus b squared. Now, if we look at the first factor as 3x quantity squared, and the 16y is 4y quantity squared, and we have the minus sign, then the question is, the middle term should be 2 times a times b, which would be 3x times 4y, which that is the case. 2 times 3 is 6 times 4 is 24. So this does fit this pattern. So if we use the a is 3x and the b is 4y, then if you remember from the pattern, this factors as a minus b quantity squared. So we would have 3x minus 4y quantity squared. Now remember, please, that this means 3x minus 4y times 3x minus 4y. And if you wanted to multiply this back together, you have to use the FOIL method. Many times people just apply the square to each term, and that would be incorrect. So our answer is 3x minus 4y quantity squared. Now in this case, we look at this and I see that m is a variable squared, and I see that 36 is 6 squared. So if we have m squared and 6 squared, this makes me think that this is the a squared plus 2ab plus b squared. So if this is the case, then the middle term should be plus 2 times 6m, which 2 times 6 is 12. And that does fit the pattern. So that means then that this should factor as a plus b quantity squared. So if we use this for a and this for b, then we have m plus 6 quantity squared. If we want to check this, we could multiply m plus 6 times m plus 6, and we get m squared plus 6m plus 6m plus 36. And so we get m squared plus 12m plus 36, which is what we had in the original problem. So this is the result. Okay, in this pattern, we look at this and we say, okay, 4a squared would be 2a quantity squared, and 25 would be 5 quantity squared. And in this situation, remember we said this will not factor in the real numbers. So if you believe it will, if we want to say, well, it's a plus b times a minus b, the problem is that would be 2a plus 5 times 2a minus 5. So if we FOIL this, we have 2a times 2a is 4a squared. 2a times negative 5 is negative 10a. 5 times 2a is positive 10a. And then positive 5 times negative 5 is minus 25. The middle terms cancel, which leaves us with 4a squared minus 25, which is not the same as plus 25. So this pattern does not work on this problem. And you can try other patterns and will be equally as unsuccessful in finding a way. So this pattern will not factor. And there is nothing you could do to factor it. So what you would write then is possibly just write 4a squared plus 25 as your answer, because there's nothing you can do to simplify that. I hope this has helped jog your memory a little bit about special factoring patterns. And if you have any questions or comments, if you'll notice, my email address is here at the bottom. And I thank you for taking time to watch this, and I hope you have a wonderful day.